Okay, in this lesson, we're going to look at simplifying algebraic expressions. The first thing that we need to make sure that we remember is our adding and subtracting integer rules. Remember, if you have the same signs, you're going to add the numbers together and keep the sign. If you have different signs, then we subtract and take the sign of the larger number. And so I want to look at just a few quick examples. Notice in the first example, 15 would be positive. 21 has a minus or negative sign in front of it, but clearly the signs are different. Those are two different signs, no matter what you call them. So we're going to subtract the numbers. 21 minus 15 is 6. And then we take the sign of the bigger number. We have more 21s, more negatives, and so the answer would be -6. The second example is one that tends to get us. Okay, if you look, the sign in front of each number is exactly the same. So that means we're going to add the numbers together and keep the sign. The next one, clearly two different signs. So we subtract. 13 minus 9 is 4. There are more positives, and so we're going to keep that as +4. You don't have to write that positive sign, but I think sometimes it helps just to make sure that we've double-checked our signs. Okay, here we don't want two signs right in the middle together like that, especially if they're both minus signs. So we're going to take that. We're going to change those to a plus because two negatives makes a positive. And so now our problem reads -13 plus 15. Notice our signs are different. So we're going to subtract and take the sign of the bigger number. And so it would be +2. Okay, you have a bunch of vocabulary right here. You may want to take a minute and pause the video and just read through the vocabulary. We have an expression, which is a mathematical phrase made up of numbers, variables, and operations. Remember, with an expression, there is no equal sign. We're going to talk about terms. Terms are what make up the expression and are separated by operations. We have constant terms, terms without a variable. We have variable terms, terms with variables. And I'm going to show you all of these things in the example below. We have a coefficient. We have like terms, which are terms with the same variable part or no variable part. And then I wanted to make sure we knew what the word simplified means. It means make it as small as possible, combine any like terms. And so let's look at this expression right here that I gave you as an example. 7p, -1, -9p, and 5. Each one of those is considered a term. They're all separated by adding or subtracting. 7p and -9p, notice I'm taking the sign in front of it with it. Those are both considered variable terms because they have a variable, right? These would also be considered like terms because they both have the same variable part. They both have the p. -1 and 5, those are examples of constants or constant terms because they have no variable. They're just a number. They are also another example of like terms because they have no variable parts. They're just numbers. We can put numbers together. The other vocabulary I wanted to point out is the word coefficient. So if we look at our variable term, it's the number part. So 7 is the coefficient on 7p. -9 is the coefficient on -9p. Okay, so let's look at some of these examples and talk about how we simplify this expression by combining like terms. So we're going to just start with 5h. You can highlight, you can color, you can circle, box, whatever you want to help you identify what your like terms are. So we have 5h, and notice the other term that has h with it is 7h. So we can put that together. And all we have to do is combine the coefficients. So 5 plus 7 is 12. So I'm going to write 12h. I just tack the h onto the end. And then my other pair of like terms are -6 and -8. Notice they both have the same signs, so we're going to add and keep the sign. So if we add them together, it's 14. Our sign is negative. So our simplified expression would be 12h minus 14. Okay, looking at the next one. We have 5x, -x, and 3x, okay? What I want to point out in front of the x is that there's no number, there's no coefficient right here. So this is an understood one, or in this case, -1. So I'm going to put them all together. 5 minus 1 is 4. 4 plus 3 is 7. So 7x, and then I also have the like terms of 7y and 2y. So 7 plus 2 is 9. This is positive, so positive 9y. And so there would be my simplified expression. Okay, next one's a little different because I wanted to point out that they have to have the same variable part to be like terms. So we have 8k squared, and so it can only go with k squares. Not only does it have to be the same variable, but it also has to have the same exponent. Now I'm going pretty fast, so at any point you need to stop, pause, go back, rewind. Please take the time to do that. So when I put those together, 6, 8 minus 2 is 6, and then the variable part stays exactly the same. Nothing changes about k, nothing changes about the exponent. Then I also have -k minus 5k. Remember, this is an understood -1 right there, so the signs are the same. Add them together and keep the sign. And then lonely old 7, it doesn't have anything to put with it, but we still have to include it, so we just tack it on to the end. Okay, for number 4, I want you to go ahead and see if you can do it yourself. And pause the video, and when you're ready, turn it back on and we'll check it. So we've got a squared, -10a squared. Remember, this is an understood 1 minus 10, which would be -9a squared. And then we have 7a plus 2a, which is 9a. Okay, so now if you'll just go ahead and take a minute, answer the question down at the bottom, and then put these notes into your notebook.